Hey everyone, welcome back to the channel. In this video, we are going over the predicted topics for GCSE Maths papers 2 and 3, mainly for Edexcel, based on what came up in paper 1. We'll be using the content and patterns from paper 1 to make some educated guesses about what could come up next. Whether you are aiming for a grade 4 or pushing for that grade 9, this video will help you focus your revision and boost your confidence. Now remember, these predictions are not guaranteed. They are based on past trends and what we saw on paper 1, but exam boards can include any topic on any paper. So please keep that in mind and make sure that you revise the full specification. Now, to make it easier for you to process, I've kind of split this under different topics. So under the number topic, I think these are some possible questions that could come up in your exam. Estimation techniques. Now, in the past, they have asked questions like the number of heartbeats per day for a person is 10 to the power of 5. And if this person lives for a period of, let's say, 81 years, estimate the total number of heartbeats that the person will perform during his or her entire lifetime, something like that. Right? I think this came like 5 years ago. So the question, to find the total number of heartbeats. Now, remember, this is per day, in a day. Now, to find the number of days in 81 years, all you need to do is multiply 81 by 365. So the total number of heartbeats will be 81 multiplied by 365 multiplied by 10 to the power of 5. It's a huge number. So this is the answer. Now, to simplify this, because it's an estimation question, 81 can be thought of as 80. 365 to one significant figure, let's call it 400, times by 10 to the power of 5. You can put this in the calculator. 8 times 4 is 32. And you can see 1, 2, 3, and there's 5, that's 8 zeros. So 32 and 8 zeros. You can write this in the standard form as 3.2 times 10 to the power of 9. The next thing you can get is calculations with fractions. Now, it's a relatively simple one, especially in a calculator paper. You can get addition, subtraction, multiplication, and division. Usually, because it's a calculator paper, it will be a part of a different question. It could be a ratio question with some element of fractions or something like that. Also, you can get a fraction of an amount. Like, they might say, a person gives 2/3 of 600 pounds to his friend, something like that. So it could be of means multiplication. So it could be a part of your question rather than a separate question on its own. The next thing you can get in this paper is percentages. Now, percentages is a big topic in GCSE Maths, and you can get multiple different variations of this. For example, you can have questions where a fraction is converted to a percentage or a percentage is converted back into a fraction. Then you can have a decimal converted to a percentage and a percentage is converted back into a decimal. Then percentage of an amount. Again, it could be a part of a question where you need to find 21% of 340 kilograms or something. Then you can have percentage increase and percentage decrease. So it could be a situation where they say a person has a mass of 80 kilograms and this person goes on a diet and loses 12% of his or her body mass. So 12% down means 100%, take away 12%, that is 88%. As a multiplier, it's 0.88. So you need to multiply 80 kilograms by 0.88 on your calculator. So you get it's 70.4 kilograms as the mass of this person, body mass of this person at the end of the diet. Something like that. Percentage increase can work in a similar situation. For example, they might say the monthly salary of a person is 1,500 pounds and this person gets 10% increase in his salary or 20% increase in his salary, something like that. So it's 100%, add, let's say it's 10%. Now that's 110%. As a multiplier, you divide by 100. So you get it's 1.1. So the new monthly salary is 1,500 multiplied by 1.1. And you get 1,650 pounds. Something like that. Percentage increase and decrease, very common. Then you can get percentage profit and loss. Again, this could be a situation where someone is buying a car for £2,000 and selling it for £2,300. What is the profit? Then you can have reverse percentage questions. Now, this is a really important topic. Imagine a situation like this. The price of a certain garment, like it could be like a shirt or something, the price has reduced by 20% and the new price is now £25. This is the new price after 20% reduction. So the question is, work out the original price. So we know this £25 is actually 80%. So 80% is what this person pays. How do we know? Because it's 20% less than 100. So 100 take away 20 is 80. So 80% is £25. So you can work out what 1% is. So how do we do that? Divide both sides by 80. So if you divide 25 by 80, you get 1% is 0.3125. So what was the original price? So if 1% is this much, what was 100%? You multiply this by 100. So it was £31.25 to start with. Now that was the original price. Now from that, when you get 20% off, you get £25. The next two topics that you can get under this topic are simple interest and compound interest. Simple interest, where you get a certain amount of percentage charged or paid and the same amount every year. Then you can have compound interest and depreciation. Compound interest and depreciation. So that is the next topic here, this one here. So in this topic, you get a situation like the price of a house increases by 10% every year. So if the initial price of the house was £200,000, how much is this house worth after 5 years or something? So what you need to do is you need to find the multiplier. So 10% on top of 100 gives you 110%. And the multiplier now is you divide by 100 is 1.1. Now, if you want to find the value of the house after 5 years, what do? You multiply this one by 1.5 raised to the power of number of years. So you need to put this in the calculator. 200,000 multiplied by 1.1 to the power of 5 gives you 322,102 pounds, something like that. Now, depreciation means the value is going down. So an ideal example would be a car. So if you think about if a person bought a car for, let's say, £20,000, and the value of this goes down by 15% per year, per annum. Every year it goes down by 15%. Now we need to find the multiplier. So it's 100%. Remember, it's going down. So I have to take away 15%, which gives me 85%. To get the multiplier divided by 100, it's 0.85. So if you want to find the value of this car after 3 years, what you do? You multiply 20,000 by the multiplier 0.85 to the power of 3. And all you need to do is just put in the calculator. And you get it's 12,282 pounds and 50 pence. So this is the value of the car after 3 years because of the depreciation. So depreciation is the opposite of appreciation, where the value is going down. The last subtopic under percentages is repeated percentage change. Repeated percentage change. So here what happens is the price of something keeps on changing by a certain number of times. Now here you can see a slightly tricky question on this topic. The value of a car is decreasing by X% each year. The car will half in value in 4 years. Work out the value of X. Now usually if they give you the initial value and the percentage, it goes down by 5%, 10%, whatever, it's very easy. Now, if they don't give you the percentage, it's a little tricky. So this is how we do this question. Let me show you how to do this question because it's a good one. Now, let's say the value of the car when it was bought at first, call it V for value. Now, the question says it's decreasing by X% and it'll half in value in 4 years. Okay. So after 4 years, the value of the car is now half of what it was, so which is V over 2. Now, the problem here is we cannot work out the multiplier. So when we don't know the multiplier, let's call the multiplier M. So what we do now, the initial value of the car, which is V, is multiplied by your multiplier M to the power of 4. And that gives you the new value, which is half of the initial value, that is V over 2. So let's write this down, V divided by 2. Now you can see from both sides, this V gets cancelled out. Or you can just imagine just dividing both sides by V. So V gets cancelled out. So on the left-hand side, I get M to the power of 4. On the right-hand side, there's nothing in the numerator. The denominator is 2. Oh, M to the power of 4 is half. So M is half to the power of quarter. Now look, right now some people might find this a little confusing, but think about it like this. If X squared was 100, how do I get X? You root it, take the square root of it. Or if Y cubed is 125, how do I get Y? You take the cube root of 125 or 125 to the power of a third, which gives you 5. Like that, if M to the power of 4 is half, M is half to the power of a quarter. Now, these kind of questions will only come in a calculator paper, so you just put this in the calculator. Now here I get 0.84089 ... So as a percentage, I know I have to multiply it by 100. That would be 84.089%. Now, we know we got this 84% by 100%, take away X% gives you 84.089%. So obviously, how do I get X? 100, take away the answer. So here I get 15.9%. It's a slightly tricky one, but that's what repeated percentage changes can look like. So I think that's pretty much what you can get in the percentages topic, some sort of a combination of the things we discussed here. Next, we are going to discuss about recurring decimals. Now, in paper 3 and 2 in the past, there was questions like convert 0.457 into a fraction, or prove algebraically that this can be given as a certain fraction. So questions like this, what you need to do, you can make X is equal to 0.457. Now these two are repeating, so 57, 57, ... Now sometimes you get questions like 0.83 and recurring notes like that, where all of them are recurring. Sometimes you can get questions, these questions can be a little tricky, like 3, 5, 2, and only the last two are recurring. The first 3 is not recurring. That can be a little tricky. Like this example I took first is one of those questions. Also, you can get questions like 3.54 and these two are recurring. So the first number is not 0, it is a whole number, some other number. So that could also be another style. So let me just show one of them. So if x is equal to 0.4575757, there are two recurring places, so I need to multiply this by 100. So I get 100x is equal to, multiply this one by 100, 45.7575 dot dot dot. Now you're going to take these two away. 100x take away 1x is equal to 45.7575 take away 0.4575 dot dot dot. Now you can clearly see all of these things go to zeros, and 7 take away 4 is 3, and that's 45.3. On the other side, you get 99. X is equal to 45.3. Now divide both sides by 99. And you can see these two gets cancelled out. So you get x is equal to 45.3 divided by 99. Now in a non-calculator paper, you can multiply top and bottom by 10 and you can get rid of the decimal. But in a calculator paper, you can straight away just put 45.3 over 99 and it gives you the fraction. And I just got on my calculator 151 over 330 as the answer. Recurring decimals to fractions, proof style questions. The next important topic is bounds, upper and lower bounds. Now, you can get relatively simple calculations on this where you just need to find the upper bound or lower bound or error interval, or you can get a question to do with the suitable degree of accuracy. Now, this is a very popular question in paper 2 and also in paper 3. The next important topic is bounds, upper and lower bounds. So you can get questions where you can get, for an example, speed is equal to distance divided by time, and they'll give you the distance is a certain value and the time is a certain value, and they'll tell you this is to two significant figures to one decimal place or whatever. So we can work out the upper bound and lower bound for distance, upper bound and lower bound for time. Now, using that, you can get the upper bound for speed. So to get that, you need the upper bound for distance divided by the lower bound for time, because the maximum distance in a shortest possible time gives you the upper bound for speed. You can also get the lower bound for speed by dividing the lowest possible distance by highest possible time. Once you get that, the two answers, you need to round it to significant figures starting from 1 SF. If they agree, no problem, then go to two significant figures. If they also agree, no problem, go to three significant figures. If they don't agree, so you get like different answers there, we know that we cannot go up to three significant figures. You take a step back and you give your answer for speed as the value that you get for two significant figures, because both upper and lower bounds agree. I'm not going into a lot of details here, but questions like this, if you're not familiar with it, please make sure that you make yourself familiarized before the exam. Algebra. In the algebra topic, these are some of the topics that I think you could possibly get. Expanding and factorizing expressions, including triple brackets. Now, this is pretty common. So for an example, x minus 3 multiplied by 2x add 3 multiplied by x minus 5, something like that. So you need to multiply two of the brackets first and then you multiply by the other one. I would recommend that you do these two first, which will make it a little easy. Most people do the first one and second one. That's okay. You get the same answer. But when it comes to your multiplication, like you get the first two terms, and these two, when you multiply, you get a quadratic expression with three terms. When you multiply by this first term here, your layout will be much cleaner if you do it like that. You can do it either way, but this would be beneficial. So triple brackets. Simplifying algebraic expressions including indices and surds. For an example, questions like this are quite likely. So you need to solve and find the value of x. 5 to the power of x is 5 root 5. So what you need to do here, 5 to the power of x is equal to 5 is 5 to the power of 1. Square root is the same as to the power of half. You can put half or 0.5. Now, 5 to the power of x is equal to, when you multiply, you add the powers. So 1 and half needs to be added. So you get 1.5, 5 to the power of 1.5. Now, 5 to the power of x is 5 to the power of 1.5. So the value of x is 1.5. So I've seen sometimes students struggling with these kind of questions, but popular exam style questions. Here's another question like that. Again, find the value of x. 27 to the power of x is equal to square root of 9 to the power of 30. If you want to try questions like these, obviously pause the video, try it, and then check. So remember, square root means to the power of half. 9 to the power of 30 square root is the same as 9 to the power of 30 raised to the power of half. When you have a power of a power, you multiply the powers, so 30 times by half, which gives you 9 to the power of 15. So we can write 27 to the power of x is equal to 9 raised to the power of 15. Now, 27 and 9 both can be written as powers of 3. So 3 to the power of 3 is 27. 3 times 3 times 3 to the power of x is equal to 3 to the power of 2. 3 squared is 9 to the power of 15. Now you can multiply the powers. 3 times x is 3x. So 3 to the power of 3x is equal to 3 to the power of 2 times 15 is 30. Now you can clearly see 3x is the same as 30. Oh, so if 3x is equal to 30, x is obviously 10. Next one, solving linear and quadratic equations. Now, this is a very common exam style question. I mean, so many past papers contain questions like this. A question like this. X add 2 over 2, x add x minus 2 over 3, x is equal to 5. Now, you can get simpler questions than that, really easy ones as well. But this one is a good exam style question. Now, step 1, I need to get the same denominator to combine them. So I'm going to multiply this one by 3. If I multiply this one by 3, obviously I have to multiply this one by 3. Now here I need to double it. I have to do the same thing to the top. Now let's write this down. The denominator, the common denominator is 6x, because 3 times 2x is 6x. 3x times 2 is also 6x. 3 times x, 3x, plus 3 times 2 is 6, plus 2 times x. If you want, you can put it at the front, that's okay. 2x, take away 2 times 2 is 4. Remember, it's negative 4 is equal to 5. Now let's simplify this further. 3x and 2x are like terms, which gives you 5x. 6 take away 4 is 2. Now, this division 6x, I can move to the other side where it becomes multiplication 6x. I'm going to move the 5x to the other side. 2 is equal to 30x take away 5x. 2 is equal to 25x. Divide both sides by 25. 25. X is equal to 2 over 25 as a fraction. If you want, you can also convert it into a decimal as 0.08. Either way, it's okay. Solving quadratic equations is again a very popular exam style question. Let's have a look at an example. Let's say you have a question like this one. So the question is, you need to solve it. So step 1, you need to multiply the first number by the last number. So 2 times negative 3 gives me negative 6. Now, factors of negative 6, negative 1 times 6, negative 2 times 3, 1 times negative 6, and 2 times negative 3. Now, I need to find the pair that add up to the middle number of 5. Obviously, that will be 6 and negative 1, because 6 take away 1 is 5. So I'm going to replace the middle number by that. So I get 2x squared minus 1x plus 6x take away 3 is equal to 0. Factorize these two and these two. I can take x out as a common factor. 2x take away 1 plus 3 out as a common factor. 2x take away 1 is equal to 0. These two are the same, so I can factorize once again. 2x take away 1 is one factor. X add 3 is the next factor, is equal to 0. 2x take away 1 could be 0, or x add 3 could be 0. So solve this one. 2x is equal to 1. X could be half. That's one possibility. You move the 3 to the other side, or x is equal to negative 3. So for this question, there are two possible answers here. You can also do quadratic equations using the quadratic formula or completing the square. Next topic is algebraic fractions. Now, this is a very common question. You get it almost every year in one of the papers at least. Here's an example. Simplify 1 over 2m squared plus m minus 15 times by 3m squared plus 9m over 1. Now, you can clearly see the only thing I can do with this one is factorize. So, but how can I factorize it? I can take 3m out, 3m squared, 1m remains there. 9m divided by 3m is just 3. 3m times m, 3m squared, 3m times 3, 9m. So that's all I can do. So these two are the same. Now what can I do with this one? Obviously, factorize it. So 2 times negative 15 is negative 30. So I need to think of factors of negative 30. That gives me plus 1, because the number in the middle is 1. Obviously, that will be 6 times negative 5. So let's try this one. 2m squared plus 6m minus 5m minus 15. Now I can factorize these two and these two. So 2m is a common factor, m add 3, minus 5 is a common factor, m. Negative and negative is positive. 15 divided by 5 is 3. I know I'm on the right track because I got the same thing, which I can factorize again. So m add 3 is one factor. 2m take away 5 is the other factor. So I know this expression is the factorized version of this. So we can see 2m squared plus m take away 15 is the same as m add 3, 2m take away 5. Also, this expression here is the same as this one here. So what I need to do, I need to rewrite it, but replacing the one I got. So let's do this. 1 over, instead of this, I'm going to write m add 3, 2m take away 5, multiplied by 3m bracket m add 3. Now you can see clearly I can cross this m add 3 and this m add 3. So my final answer is 3m over 2m take away 5. I cannot simplify it any further, and that would be the final answer. Next one is simultaneous equations. You can get linear and nonlinear. Let's look at each one. Think about an example of a linear simultaneous equations. You have a pair of equations like these two here. Now, you need to see whether you have the same a's or b's. You don't, so you need to make them the same. So you can either make a's the same or b's the same. So I'm going to make b's the same here. So I've got 2 here in front of this, the coefficient of the second b here. So I'm going to multiply the whole of this first equation by 2. And I got 3 here. So I'm going to multiply all of this one by. Now, some people write this 3 here I'm not a big fan of that method because people tend to forget multiply all three terms in a haste during an exam. Sometimes what happens is they do 3 times 5, 3 times 2, and they forget to multiply the 18, and that can lead, to a wrong answer from there. So I would personally say put the 3, 3, 3, 2, 2, 2. It's only going to take 10 seconds extra, and it's going to make sure that you're going to get the right answer. 2 times negative 3b is negative 6b is equal to 22. Now this is my new equation 1. 5a times 3 is 15a plus 3 times 2 is 6b is equal to 18 times 3 is 54. My new second equation. Now I'm going to put a circle around the things that are the same, and I'm going to pay attention to the sign of those two. And I can see one of them is plus, the other one is minus. So opposite signs. And remember, whenever there are opposite signs, you need to add. So let's add them. 15a add 4a is 19a. Minus 6b and plus 6b get cancelled out. 54 add 22 is 76. These two gets cancelled out. A is equal to 4. Now, all I need to do is substitute a is equal to 4 in equation 1. The first one here, you can actually substitute in any of them. So, 2a minus 3b is equal to 11. Let's substitute a is equal to 4. So, I get 8 minus 3b equals 11. So, I can move 8 to the other side. I get negative 3b is equal to 11 take away 8 is 3. Now divide both sides by negative 3. These two gets cancelled out. 3 over 3 is 1, but it is negative 1. So I can write my answers. A is equal to 4 and B is equal to negative 1. Now in questions like that, always check your answer with the second equation. Now, if you used equation 1 here to check, use the other one. So let's see if that works. A is 4, B is negative 1. So let's put 4 here. 5 times 4 plus 2 times B is negative 1. Negative 1. Let's see what you get. 5 times 4 is 20. 2 times negative 1 is negative 2. 20 take away 2 is 18. Do I have 18? Of course I do, so I know I'm right. That's linear simultaneous equations. Non-linear simultaneous equations. So you have one linear equation like this one, the second one, and the other one is a quadratic. So quadratic simultaneous equations is a very common exam question again. Now, the good thing about these type of questions is you always do the same thing. So you need to start with the linear one, and you need to make one of the letters the subject, A or B in this case. Obviously, making A the subject is a lot easier, so I'm going to move 2B to the other side. I get A is equal to 5 add 2B. Now, all I need to do is substitute this in the quadratic equation where there is A. Oh, here. So instead of A squared, I can write 5 add 2b, everything squared, plus b squared is equal to 25. Now, I don't have any a here. I can just do normal quadratic. So let's do that. 5 add 2b multiplied by 5 add 2b plus b squared is equal to 25. So 5 times 5, 25 plus 5 times 2b, 10b, 2b times 5, 10b, plus 2b times 2b is 4b squared, and plus this other b squared at the very end is equal to 25. I have 4b squared and b squared, which gives me 5b squared. Then I got 10b add 10b, which is 20b. Now, I have a 25 here, so I'm going to move that 25 to the other side. where I get 25 take away 25. Now I get 5b squared plus 20b is equal to 0. Now I need to factorize 5b here. B add 4 is equal to 0. 5b times b, 5b squared, 5b times 4, 20b. Now, when these two multiply to give you a 0, so you can see obviously it's either 5b is equal to 0 or b add 4 is equal to 0. So if 5b is equal to 0, b is also 0, or I can move the 4 to the other side, b is equal to negative 4. So I got two values for my b's. Now what we need to do, we need to substitute each one in the linear equations. I'll probably do it in this one to get my a's easily. So I need to find a's. So let's do this one here. So a is equal to 5 plus 2b, but I know b is 0 here. So a is equal to 5. Now here, a is equal to 5 plus 2 times negative 4. So which is 5, 2 times 4 is 8, negative. That gives a is equal to negative 3. Now, this is really important. You don't leave the answer just like that. You need to pair them up. So I'm going to color code it to show this one. When a is 5, b is 0. That's one pair of answers. Also, when a is negative 3, b is negative 4. So I'm going to write both my answers clearly. So this is my final answer. Please make sure that you give the pair a and b and then the other a and b. Now don't make the mistake of writing the two b's together and then writing the two a's together. I've seen this multiple times. Please make sure you don't do this in the exam. If you want to check these, substitute it back in the second one and it should work. Next topic is inequalities. Now, you can get different variations of inequalities. You can get very simple inequalities where you need to plot this on a number line. For an example, x is less than or equal to 4. So you need to go to the point where x is equal to 4. And because it's less than and equal, so you draw a circle, but with the equal sign, you need to color it. And then you need to go like this, because x is less than or equal to 4. Now, if the question was like this, then you need to put a circle at -2, and you need to put a circle at 3. So x is in between, but be very careful here. You can see here there's an equal sign. So I need to color this circle. The other one is just less than 3. So 3 is not included. So I need to go like that. So the value of x in this example could be, the integer values are -2, -1, 0, 1, 2. But you don't count 3 because it's not equal to 3 but less than 3. The other kind of question you can get on inequalities is about solving inequalities. But I think there was a question like that on paper 1. So it's unlikely that you get this in the second or third papers. Unlikely. The next type of questions you can get on linear inequalities is inequality regions. So you can get, so these are the questions where you have 3 inequalities usually, where one of them goes like that, the other one goes like this, and the other one goes like this. And they ask you to shade the region that is common for, that is covered by all 3 of them. So in this example, it will be the triangle in here. So this one could be like x is equal to 2. Oh, so what you need to do is you need to draw those lines, and you need to pay attention again. If it is equal, you can use a solid line. But if they give you, say for an example, x at y is less than 3. So x at y is equal to 3. is a line like this because it goes to 0, 3 and 3, 0. Now it's less than 3, so it's the bit on this side. However, because it's not equal, we need to draw this line as a dashed line, not a solid line. This line should be a dashed line and not a solid line if it is less than or more than. And there's no equal sign. If you have the equal sign, then obviously you need to draw a solid line. The next one you can get on this is quadratic inequalities. So it could be a question like this. Now, the first step is you need to factorize this to find the critical point. So I can put x here, x here. So negative 3, add 1. Negative 3 times 1 is negative 3. Negative 3 add 1 is negative 2. So it's okay. So I can see the critical points are x is equal to 3 and x is equal to negative 1. So what that means is when I get the graph cuts the x-axis at point 3 and negative 1. So this is 3. This one here is negative. Now, x squared minus 3x minus 3. Now, this is my function. It's less than 0. Now, I can see this is less than 0 in this region here because it goes to the negative side. So, my answer is negative 1 x and then negative 3. This is the final answer. Next topic is functions. Now, in functions, you can get questions about inverse functions and composite functions. So let's consider them one by one. Inverse functions. Now, you get questions like this. Find the inverse function of x when f of x equals x cubed over 2 add 1. So here are the steps. The first step is write y is equal to the function. Okay, so let's replace f of x by y. Y is equal to x cubed over 2 add 1. Then make x the subject. Oh, that's easy. Move 1 to the left hand side. Y take away 1 is equal to x cubed over 2. Move the 2 to the other side. 2 bracket y take away 1 is equal to x cubed. To make x the subject, I need to cube root both sides. X is equal to cube root of 2 bracket y take away 1. Now, to get the inverse function, all you need to do is replace y by x. You know this y that you get here. Just put x there, then you get the inverse function. So you get cube root of 2 bracket x take away 1. This is the expression for the inverse function. The next one is composite functions. So composite functions kind of look like this. F of x equals x over 3 add 4. G of x equals 6x cubed plus 3. They can ask you what is f g of x. So we start with the function that is inside, which is g of x. So all that means is you need to use g of x and you need to feed it to f. So what's your g of x? G of x is this. So this we are going to feed to this x here. So whatever you drop here will go there. So what do we get? F g of x is equal to, now 6x cubed plus 3 goes here and then that goes here. So we get 6x cubed plus 3 over 3 and 4. Now just normal simplification. I can see I can factorize by 3 here. 2x cubed and 1. 3 times 2x cubed is 6x cubed. 3 times 1 is 3. That's okay. Over 3 and 4. Now I can see this 3 and this 3 cancels out. So I get add 1, add 4. So I can combine. I get 2x cubed add 5 as my final answer. The next topic is sequences. Now, in GCSE maths, you can get different variations of sequences. Now, the first type is arithmetic sequences. So, arithmetic sequences are when you have something like 7, 9, 11, 13, ... Now, to identify it, you have a common difference. So, you go from 7 to 9, you add 2. 9 to 11, add 2. Same thing here. Or you take away 20, 15, 10, 5, like that. So these are arithmetic sequences. Now to find the nth term of a sequence like this, first you need to find the common difference. And you can use this small technique called Dino or Dino. Or if you just know how to do it without it, that's fine. So the first DI stands for the difference. The difference here is plus 2. Then this letter N goes here. And, this is your first term. This is your second term. So we need to work out the 0th term, the 0 term. So what was the term before the first term? So obviously, to maintain the pattern, that must be 5 and it's positive 5. So this 0 here, dino, this O here stands for the 0th term, which is plus 5. Some of you might do this in a slightly different way. It doesn't matter as long as you understand, as long as you get the same answer. So this is how you find the nth term of an arithmetic sequence. Next one is geometric sequences. In geometric sequences, you have a common ratio. For an example, 5, if you double it, 10, double it, 20, double it, 40, ... So to identify a geometric sequence, you can divide any term by the previous term and see what happens. For an example here, if you divide 10 by 5, so any term divided by the previous term. 10 divided by 5, so we can say the common ratio is 2. So 5 is multiplied by 2 to get to 10. 10 is doubled to get 20. 20 times 2 is 40. Remember, in arithmetic sequences, you have a common difference, and here we have a common ratio. Now, to get the nth term of something like this, we use the formula a times r to the power of n minus 1. And this a here is the first term of the sequence, and r is the common ratio, which you find by any term divided by previous term. So for the sequence here, this one, it will be a is 5, because you can see it's 5, the starting term, times r is 2 to the power of n minus 1. Now you can use this to get answers to questions. For an example, let's just try. In this sequence, what is the fifth term? So let's put 5 for n. So you get 5 times 2 to the power of fifth term, 5 take away 1. 5 take away 1 is 4. So 5 times 2 to the power of 4. That is 5 times 2 to the power of 4 is 16. 16 times 5 is obviously 80. And is that the fifth term? 1, 2, 3, 4. Yes, it is. See, it works. If you want to find the 100th term, just put 100 for n. You get it. So that's about geometric sequences. Next one is quadratic sequences. Here's an example of a quadratic sequence: 7, 18, 33, 52, ... Now let's see how that works. 7 add 11 is 18. 18 add 15 is 33. 33 add 19 is 52. Now you can see the first difference here is 11 and then it's 15 and it's 19. So it's not the same. So there is a variable first difference. But let's look at the second difference. Second difference is 11 to 15. It's add 4. 15 to 19. Oh, it is the same. So remember, if you have a sequence where there is a variable first difference, changing first difference, but constant second difference, we call that a quadratic sequence. So this one here is a quadratic sequence. So how do we find the nth term for this? Let's use the same example. Now the general formula of a quadratic sequence is given by an squared plus bn plus c. The a, b and c here are numbers, constants. Now there are three formulae that you need to know. 2a is second difference. Second term minus first term is 3a at b. First term is a at b and c. You need to memorize these things and it will make it so much easier. You can derive these things starting from the basic principles, but I think this video is not the place to do that. So second difference is 2a. Now what's the second difference here? 4. Okay. So let's write 2a is the second difference for, obviously, a is 4 divided by 2, 2. So I just figured out the value of a. Now, I've used this one now. Let's go to the second one. Second term take away first term is 3a at b. So second term take away first term here is second term 18, take away 7, which is 11. Okay. So 3a at b is equal to 11. Now, I already know my a because I just worked it out. So all I need to do is substitute it here. So 3 times 2 is 6 and b is equal to 11. So I just got my value of b as well. So use this one. Now the last one, first term is a at b at c. First term is 7 in this example. Okay, so let's write it. A at b at c is 7. Now I already know my a here is 2. So I can substitute it here. I also know my b here is 5. So I can substitute it here. So let's do this. 2 add 5 add c is equal to 7. Now 2 add 5 gives me 7 add c is 7. Take the 7 to the other side. 7 take away 7 is 0. So the value of c now is 0. So when I have the values of a, b and c, I can easily get my final answer. Put it in this formula. So a is 2. So 2n squared. B is 5 plus 5n plus c. C is 0. I mean, you can put plus 0 or just don't worry about it because it's not going to change anything. Now, my final answer is 2n squared plus 5n. Now, let's see if that works. Just to try for the third term. So, let's say n is 3. For the third term, n is equal to 3. So, when n is equal to 3, 2 times 3 squared plus 5 times 3. 3 squared is 9 times 2 is 18 and 5 times 3 is 15. 18 and 15 is 33. Now let's see if that's my third term. Yes, it is. So that works. You can put 4, 5, anything, and it works just the same way. So this is the quick way to do this kind of quadratic sequences. Only thing is you need to memorize these three formulae, the ones in the bubbles here. But once you do that, you can obviously do this very quickly and easily. And then about the special sequences, you don't really get that many questions on this in these papers, but there are square numbers. 1 squared, 2 squared, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, ... You can also have cube numbers, like 1 times 1 times 1 is 1, 2 times 2 is 4 times 2 is 8, 3 times 3 is 9 times 3 is 27, 4 times 4 is 16 times 4 by again 64, 5 times 5 is 25, times by 5 again, 125, dot, dot, dot. So these are some special sequences. The next special sequence you need to know is triangular number. So 1 is a triangular number. If you add 2 underneath that, that will form a triangle again. That's 3. If you add 3, then you get 6. Then you get 10. Then you get 15, dot, dot, dot. And then last one is Fibonacci sequence. Now, the Fibonacci sequence, sometimes you start from 0, sometimes you start from 1. They usually specify this. That's if you start from 0, then 1. 0 add 1 is 1. 1 add 1 is 2. 1 add 2 gives me 3. 2 add 3 gives me 5. 3 add 5 gives you 8. You get the point. 8 add 5, 13. 13 add 8, 21, dot, dot, dot. So basically, to get any term, you need to add the previous two terms. If you take from any random place, 1 add 2, see, that's 3. What about 2 add 3? That's 5. 3 add 5, 8. 8 add 5, 13. So the next term here should be 21 plus 13, which is 34. So that will be the next term. So this is Fibonacci. You can get questions on this sometimes. Next, we are going to look at geometry and measures topics that you can possibly get. Properties of 2D shapes is a pretty common one about angles in polygons and related things. So you can get questions to do with those things, and also with symmetry, you can get line of symmetry and also rotational symmetry, although it's not very popular, but they can come towards kind of in the beginning of the paper. Then you can get area and perimeter related questions. Sometimes it's connected with algebra. There was a question a couple of years ago, and this question had a rectangle, and they've given some expressions for the length of the side. Say this is 3x at 2, and the other one is 5x minus 12 or something like that. And then this was x at 2. I'm just making this up, something similar to this, right? And the question was to either find the area or something like that. So the idea here, the thing I need to retalk here, is because this is a rectangle, obviously we know that these two sides are equal in length. So 3x add 2 is equal to 5x take away 12. And then you just move it to that side, move it to that side. 12, 2 add 12 is equal to 5x take away 3x. Now you can say 14 is equal to 2x and x is equal to 7. Then from there you can just work out the rest of it. You know, simple questions with properties of 2D shapes. Next one is circle theorems. There are 7 circle theorems that you need to know for GCSEs. Here's the first one. Angles in the same segment are equal. So if you start from the same 2 points on the circumference of a circle, the angles subtended by those 2 points on anywhere on the same segment, like it could be this one, this one, this one, or I can even, you know, start from here. These should be straight lines using a ruler. I draw these lines. All of these angles are always the same. And the wording is angles in the same segment are equal. And here's the second one. Angle on the center is twice the angle on the circumference. So if you start from the same 2 points here and here, and if you draw 2 lines so that you make an angle 2x, whatever the value, on the center, starting from the same 2 points, if you go to any other point on the circumference like this, or even like that, wherever really, it doesn't really matter, kind of connecting us to the first one, angles on the same segment are equal, so these are equal. So the angle on the center is always twice as much. If this one here is 50 degrees, that's going to be 100 degrees, like that. Now, there's a tricky one here for some people. I've seen this quite a lot. Let me show you. Let's say if you start from here, those 2 points, and you go to this point here, like that. Now, this is the angle on the center, This is the angle on the circumference, so that will be x. Now, many students, I've seen this in the past when marking papers and all that, students tend to think, oh, these two are the same. I think they kind of get that confused with angles on the same segment are equal. Look at it very carefully. This one is on the center. This one is on the circumference. I mean, you can kind of clearly see that this is a smaller angle and this is a bigger angle. In fact, it is this rule. Angle on the center is twice the angle on the circumference. That's the second one. Third circle theorem is angle in a semicircle is 90 degrees. Now, if you start from the ends of a diameter and you can go to any point, doesn't really matter if it is here. I mean, these should be really straight lines using a ruler, and you can just do it and see you'll always get 90 degrees. Even if you go to the other side, it really doesn't matter. Irrespective of the point that you go to, if you start from the ends of a diameter and you go to anywhere else on the circle, you'll always get a 90-degree angle. Now, proof of this can also be a question that you can get in GCSE maths. On the channel, there is a separate playlist where I've done some of these proofs, so you can go there and have a look at it. But let me just briefly tell you how this one works. So this is the center. So all you need to do is draw a line like that. Now, if this angle is x, obviously this angle is also x. The reason is these two are equal. They are the radii of the same circle. So this is an isosceles triangle. So if this is x, this is x. Similarly, if you look at the other side, this and this are also equal radii of the same circle still. So if this is y, this is y. Now you can clearly see this angle here, and this big angle here, they all add up to 180. Angles inside a triangle or interior angles of a triangle add up to 180. Now y add y is 2y, x add x is 2x is equal to 180. Factorize 2 out, y add x is equal to 180 degrees. Divide both sides by 2, cross, and you can clearly see that's 90 degrees. That's one way of doing it. You can also do it by considering the angles here, but either way is fine. Here's the next one, the fourth circle theorem. Tangent is always perpendicular to the radius at that point. So if you draw a tangent at any point, and if you draw a straight line to the center, I'm just doing this freehand. So if you do it properly using a ruler, you can see it nicely. You do like that. Wherever you connect it, you always get a 90-degree angle. And here's the fifth one. You can only draw two tangents from any given point to a given circle, and those two are equal in length. And you can clearly see the black line and the red line are equal in length. Next one is opposite angles of a cyclic quadrilateral add up to 180 degrees. So here the opposite angles are A and C are opposite angles. So A and C gives you 180 degrees. Similarly, D and B are opposite angles of a cyclic quadrilateral. So that's 180. So cyclic quadrilateral is when you have all 4 points on the circumference of the same circle, and it forms a quadrilateral. Now, sometimes you might get a quadrilateral like this, like 1, 2, 3, and 4. Now you can see they're kind of on one side, but it doesn't really matter. That is still a cyclic quadrilateral because the condition is that all 4 points should be on the circumference of the same circle. As long as that is met, it is a cyclic quadrilateral. And there's another thing that you need to be careful, because I've seen this in GCSE questions quite a lot. So you have like a situation where you have 3 points on here and the fourth point is outside. So it forms a quadrilateral. Sorry about the crooked lines, but something like that. And there's some other thing, maybe another line connected like that and the question. Now, this is not a cyclic quadrilateral. Why not? Because one of the points is outside. You need to be careful with that. So don't think you can apply this, opposite angles adding up to 180 here. It must be a cyclic quadrilateral for this to work. And here's the last circle theorem you need to know, alternate segment theorem. So this is usually the one that people find it difficult to see. Like I've seen students, well, usually I tell my students, if there's a circle theorem question, and if you find it quite difficult to figure out what's really going on, check whether it is this. Check whether it has to do something with the alternate segment theorem. Now, what it really means is, if you have a circle like this, and there's a tangent here, and then there's a chord. Now the angle between these two, let's call it x. That angle and the angle formed by that on the other segment. So hence the word alternate segment. This one here, this one here. These two are the same. Hence we call it alternate segment theorem. So this angle here and this angle here are equal. I mean, you can see here, I've got it here, this angle here and this angle here are equal. Similarly, if you think about this as the chord, you look from this side and this is the angle between the chord and the tangent, and that is equal to the angle subtended by this chord on the other segment. So this is one segment, this is the other segment. So hence the word alternate segment. If you look at it, one of the green angles is on this side on one segment, the other one is on the other segment. Next one is Pythagoras theorem. You can get a lot of different questions on this one. Say if this is A, B and C, what the Pythagoras theorem says is the square of the two shorter sides added up, a squared plus b squared, gives you the square of the longest side. So in simple calculations, you can do it like this. Let's say there's a question and you have to find the longest side. So this is 3 centimeters and this is 8 centimeters. And the question is what this is. So here you can use the thing square, add, and square root. So what does that mean? You square the 3, you square the 8, you add them up, and then you root it. Put it in the calculator, you get the answer. Now let's say you get a question like this where you have the longest side given, say it's 15 centimeters, and this one is 6 centimeters, and they ask you to work out the other one. So you do the same thing, but instead of square, add root, this time it's square it, take away, and root it. When you take away small one from the big one. So square the big one, 15 squared, square the small one, 6 squared. Because you're finding one of the shorter sides, you take away and then you root it. That will give you the answer, or just put it in the formula and do it. Either way, whatever works for you. The next variation of Pythagoras theorem is 3D Pythagoras. So here's a typical 3D Pythagoras question on a cuboid. So you can see 8 centimeters, 6 centimeters, the height is 7 centimeters. So what is the diagonal that connects A to D? Now, in questions like this, the first step is finding the length AC. So you can see this one at the bottom, this one here, is a right angle triangle because B is a right angle, ABC. Here, 8, 6, and this is the line AC. A, C, and B. Now we can use Pythagoras theorem. So that will be 8 squared and 6 squared square root. 64 and 36 square root is 100 square root, which is 10. So we know this line here is now 10. So let's draw the vertical triangle, which is this one that I'm highlighting in yellow. Now, the previous triangle, the purple one is a horizontal one. This one is vertical. Now let's draw this separately. Here is X, the one you are trying to find. And here is AC, which is 10 centimeters. Now I need to connect C to D, which is the height, and we know this is 7 centimeters. And this is a right angle, which is this one here. Now all you need to do is use the Pythagoras theorem one more time. It will be 10 squared plus 7 squared square root. which gives 12.2 centimeters. Now, this is one way of doing a typical 3D Pythagoras question. Also, there's a quicker way using one formula. Let me show you that method as well. Here's the second method. Now, the formula is x, y, and z, and r squared is x squared plus y squared plus z squared straight away. So if you can do r squared is equal to 8 squared plus 6 squared plus 7 squared, and if you put this in the calculator, you get exactly the same answer as before, 12.2 centimeters. You can also get 3D Pythagoras question based on shapes like this, like square base pyramids. Two types of questions can come under this. Like sometimes they can ask you to find the length of this line here. Now, usually they'll tell you this is, say, 10 centimeters, the whole thing. So obviously we know this is 5, and they'll tell you this length is 16 centimeters, and this is perpendicular. You can find the length x here just using Pythagoras. X is equal to, so you can do square it, the long side, square the other one, 5 squared. Remember, it's this side here, right, from here to here, 5, half of 10. Take away and then square root, because we are finding one of the shorter sides. That would be one type of question you get. You can also get a slightly trickier question like this, where they ask you to work out the perpendicular height here. So to do questions like this, you need to draw a diagonal like that. And then obviously they'll give you this, say 10 and 10. And I can find the length of this diagonal, which will be 10 squared plus 10 squared square root, which is root 200. Now, half of that gives me this length here, this yellow bit here. And this length will be given, let's say it's 16. Then what you need to do is just use Pythagoras for the vertical triangle here. This is a vertical one. This one is a little tricky. This is the other type of 3D Pythagoras questions that you can get on this type of shapes. Basic trigonometry questions like basic use of sine, cosine, and tan. Sine theta equals so, sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, tan is equal to opposite over adjacent. Questions on this are really, really simple. I mean, usually these things come early in the paper 2 or paper 3, and some of them could be simply they give you this is 45 degrees and this one is 12 centimeters. Find the length of this one here. So that is the opposite. That is the hypotenuse. So you need to think about the formula. Is it so, ka, toa? Obviously it's so because opposite and hypotenuse. And then you just put the formula. Sine 45 is equal to opposite. You don't know. It's y. Hypotenuse is 12. And you bring the 12 to this side. So you get 12 multiplied by sine 45 is your y. 8.49 centimeters. You need to be careful with the rounding here. Sometimes you get like 8 point. Now here I got 8.48528 dot dot dot. What some people do is when the question says to give it to 3SF, they just truncate it here. Truncate means just stop here and think it's okay, 8.48. No, because you need to look at the number after here. So that's a 5. So obviously I have to round this up. So that becomes 8.49. Simple questions, but you still get questions like this quite a lot. Another possible question which I've been thinking about quite some time now is that they can ask you to prove this relationship tan theta is equal to sine theta divided by cos theta. This is not exactly in the specification as such, but if you think about the content, this is very likely because it's very simple maths. If you think about it, it's a direct application of these three. So let's see how it is done. So we know sine theta is opposite to hypotenuse is 1. Let's call it 1. Cos theta equals adjacent to hypotenuse. Let's call this 2. Now, if I divide 1 by 2, see what happens. The left-hand sides are sine theta divided by cos theta is equal to, the top here is opposite over hypotenuse. The other one is adjacent over hypotenuse. Now I'm going to simplify this further. So sine theta divided by cos theta is opposite over hypotenuse divided by a over h. But remember, keep flip change KFC. So I can keep the first fraction, change the second fraction over. I'm going to change this to h over a, and I change the division to multiplication. And now you can see what happens really here. This h here and this h here gets cancelled out, and you get what? O over a. But what is O over a here? We know O opposite over adjacent is tan theta. So I can clearly see tan theta is sine theta divided by cos theta. I'm not sure if they asked this one, but the proof of this is well within GCSE limits. The next topic that you can get under trigonometry is the advanced trig. Sine rule, cosine rule, and area of a triangle. Now, these questions, most of the time, these questions come only in the calculator paper. Now, sometimes you can get this in the non-calculator paper along with exact trigonometric values, but most of the time, you get these questions in the calculator paper, paper 2 or paper 3. Now, here's the sine rule. So, you label the triangle such that a and lowercase a, b and lowercase b, c and lowercase c are exactly opposite. So what the sine rule says is length a divided by sine of capital A. So a over sine A is equal to b over sine B is equal to c over sine C. So you can use any two at a given time, like you can use a and b, or a and c, or b and c. Now the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a. So we can use the sine rule, the top one, or the cosine rule for these. Some questions can use both, like you need to use sine rule and then use cosine rule, or vice versa. Next one is the formula to find the area of any triangle like this. To find the area, we can use the formula half AB sine C. Now, not only that, so half A, B, and sine of the angle included. Now, you can do the same thing, and you can see it's half BC sine A. That also works. And you can do the same thing with the remaining one. So using A and C, but this time you need to use the angle in the middle, which is B. So it is half AC sine B. So half AB sine C, half BC sine A, or half AC sine B. Now the next possible question that you can get on this topic is the proof of this. So where does this come from? Edexcel asked this in one of the specimen papers, if not a mock paper. I don't remember exactly which one. In one of the papers they asked, but as far as I remember, they have not asked this in any real exam paper since 2017. But they did ask it in one of the specimen or mock or one of those papers somewhere. So it's a possible question. I think it could come up at some point. So how do you prove it? This is what you do. Now, to find the area of any triangle, you need to multiply base by height and divide by 2. So area is equal to base multiplied by the perpendicular height h divided by 2. Now, guys, can you see there is a right angle triangle here on the right hand side? This one here. So I'm going to use that, and I'm going to get sine C is so. Opposite is your h. Hypotenuse is A. Okay. A. Now, I can move the A to this side. So what do I get? I get A sine C is h. Right, now guys, can you see? I can replace this h with a sine c. So that's what I'm going to do. So I'm going to substitute it here. So I get a is equal to b times a sine c over 2, which becomes half ab sine c. That's it. Very simple. Next topic is enlargement. This is, I think it's less likely to come compared to the other ones that we discussed here, because there were other transformation questions. There was an enlargement question, but not a negative scale factor, with a fractional scale factor in the first paper. So I would say this is a bit less likely to come, but it's good to just make sure that you know how to do the enlargement using a negative scale factor. Here's an example. A triangle has vertices at A 2, 1, B 4, 1, C 2, 3. Enlarge the triangle by a scale factor of -2. So let's see how to do this. So your answer will be something like this. Now here's the center 0, 0, and you can see A is 2, 1. So 2 to the right, 1 up. So that's here A. Now when A is 2, 1 and the enlargement scale factor is -2, if you multiply both by -2 scale factors, if you multiply both coordinates by -2, you get -4, -2. Right. Now let's say, so this is -2, that's -4, and that's -2. So that's where you have your A dash. Now, another way of understanding it is, if you draw a line connecting your point to the center, if this is 1, because the scale factor is -2, negative sign says it goes to the other side, and this is 2. See, that length, this yellow highlighted length is 1. The green length here is twice as much. And that works for all the other points as well. Or you can just use the coordinates. Now let's say B is 4, 1. Now if you multiply both of them by scale factor -2, it's -8, -2. If you check this, so -8, so you can see each box is 2, so it's -2, -4, -6, -8 is here, and then -2, and that's -2, and that's B dash. And again, if you connect B dash to B like this, and look at the length again, this pink length here is half this blue length. Why? Because the scale factor is -2. Scale factor is 2 on the other side, so you call it -2. Now the next type of question you can get is using pi in geometry problems. These are more common in paper 1, but you can still get this in paper 2 as well. Here you can see a typical question like that. If you want to try this question, pause the video and give it a try. And when you are ready to check your answer against mine, you can play it and check. Or if you feel like you want to just learn it, just keep on listening. A solid metal cylinder has a radius of 4 and height of 10. Part A. Calculate the volume of the cylinder in terms of pi. Give your answer in the form k pi cubic centimeters, where k is an integer, right? That's pretty straightforward. So part A, volume of a cylinder is given by area of cross section pi r squared multiplied by height h. So let's plug the values in. Pi times radius is 4 squared multiplied by 10. 4 squared is 16 times 10 is 160 pi. So that's the volume, centimeter cubed. So I know the value of k here is 160. But the question says to give your answer in this form, so I'm going to leave it like that. Part B. The cylinder is melted down and recast into spherical balls, which each with a radius of 2 centimeters. Okay. How many complete spheres can be made? Give your answer in terms of pi and then as an integer. Now let's see. Now, so when you melt it, basically that whole volume, 160 pi, you need to divide it by the volume of a sphere. So I know the volume of a sphere is given by the formula 4/3 pi r cubed. So when you do that, it's 4/3 pi times 2 cubed. You can just simplify this further. 2 cubed is 8 times 4 is 32 pi over. So that's the volume of one sphere. So to do this, you need to divide the whole thing by 32 pi over. So that's kind of the pi expression, because the pi is about to get cancelled out now. So I can, let's just do the division normally. So keep flip change. So I'm going to divide 160 by that fraction. So instead I can do 160 pi multiplied by, take the reciprocal, 3 goes to the top, 32 pi in the denominator. Now you can clearly see these two gets cancelled out. You get the answer as 15 exactly. So the number of complete spheres that you can make will be just 15. Next possible question is probability trace. So in width replacement style questions, you have 5 red counters and 3 blue counters in a bag, and a person takes a counter and then checks the color and put it back, and then does it another time. So what's the probability of getting red or blue or whatever? So when you draw the tree diagram, you draw it like this. And then now you can see it's 5 red out of a total of how many? 5 and 3, 8. So 5/8. Now this one is 3/8. Now because this person takes a counter, checks the color and puts it back, this is also 5/8, 3/8, 5/8, and 3/8. Now this is pretty easy. Now if they ask you, okay, how do you get the probability of getting both red? So what should we do? So it's this branch here, this branch here. So what do you need to do? You multiply the two probabilities. So it's 5/8 multiplied by 5/8. So the probability is 25/64. What about the probability of getting red followed by blue? So you multiply 5/8 by 3/8. 5 times 3, 15/64. What about the next branch? Blue followed by red. That is 3/8 multiplied by 5/8. That's also 15/64. And finally, what about getting two blues? So that's 3/8 times 3/8. That will be 9/64. Now, an important thing that you can notice is if you get all of these things, they should add up to 1. Let's see. 25 add 15 is 40. 40 add 15 is 55. 55 add 9 is 64. See, you get 64/64 or 1 when you add them up. That's an important thing to notice. So what's the probability of getting red followed by red? Here's the answer. Red followed by blue, blue followed by red, blue followed by blue. Now, if you get a question and ask like, what's the probability of getting both the same color? Now, it doesn't say which color. Only thing is they both need to be the same color. So, it can be red, which is 25/64. Or it can be blue, which is 9/64. You add the probabilities. 25 and 9 is 34/64 is your probability. So what if they ask you, what is the probability of getting one of each color? One of each color. So that means blue followed by red and red followed by blue, both. So red and blue, that's 15/64 here. Then blue and red is also 15/64, and you can see It's 30 over 64. These are probability values. You do not need to simplify this. I know you can divide them by 2 and all that. You don't need to do that. Leave it like that. It's fine. So that's how you get it. Now, another question you can ask is, okay, what is the probability of getting at least one red? Now, at least one red means red. Yes, that's one way of getting it. At least one red. Red, blue. Yes. Blue, red. Yes. You can't take blue. So what do we do? Probability of getting red is this. Red, blue is this. Blue, red is this. All you need to do is just add them up. So you get 25 over 64 plus 15 over 64 plus 15 over 64. So denominator is 64. That stays the same. 15 and 15 is 30 and 25 is 55. 55 over 64. Now, there's a quicker way to do this as well. The quicker way is this. Now, you can see when they ask at least one red, so that's basically every other scenario except for this one here, except for blue. So, I know everything add up to what? 1. So, if you straight away do 1 take away blue, which is 9 over 64. Now, when you do this, well, this is a calculator paper. Let's put it in the calculator, or consider 1 as 64 over 64. So, 64 take away 9 is again 55 over 64. You get exactly the same answer. If you think the second one is a bit more complicated, go with the first one. If you understand both of them, great. Here's a slightly trickier question you can get on this topic. There are 10 sweets in a jar. 4 of the sweets are strawberry flavor. 6 of the sweets are cola flavor. Amira picks one sweet at random from the jar. She eats the sweet. She then picks another. Now look, when she eats it, she cannot replace it, meaning it's a non-replacement type. So let's draw a tree diagram for this one. 4 of the sweets are strawberry flavor out of how many? 10. So 4 over 10. Cola is 6 over 10. Now, Amira picks one sweet and she eats it. So, for the second pick, how many sweets are there now? There were 10 to start with, and she ate one. So, this will be 9. So, remember in the second law, every denominator is 9. So, go along each branch. If the first one was strawberry flavor, if she ate a strawberry flavor one, that means there were 4. So she ate 1. Now the number of strawberry flavor leftovers are 3. If the first one was strawberry flavored, she didn't eat any of the colas. All of the 6 colas are left. Now look, these two add up to 1. That's how you know. Look, 3 over 9 and 6 over 9 is 9 over 9, which is 1. These two also add up to 1. 4 over 10, 6 over 10, 10 over 10. See, that's how you know. Now, this one. If the first one was cola, we are going down this branch now. Oh, so that means all of the 4 strawberries are left. If the first one was cola, there were 6. She ate 1. There will be 5. Again, these two add up to 1. See? She then picks another, okay? Work out the probability that Amira picks one sweet of each color. Oh, that's strawberry followed by cola, or cola followed by strawberry. Now let's get the probabilities. Strawberry followed by cola probability is 4 times, you need to multiply these numbers. 4 times 6 is 24 over 90. This one is 6 times 4, 24 over 90. The total probability, you just add them, common denominator 90, 48 out of 90. You can simplify this, but you don't need to. That's the final answer. Capture-recapture method or sampling populations is another popular exam question. I'm going to explain it with this example. A park ranger wants to estimate the total number of rabbits in a nature reserve. Now, this is an important word, estimate. It's not an exact value. The person wants to just estimate. On Monday, she catches 180 rabbits. Now, let's assume that the total number of rabbits in this particular environment is X. So, she catches 180. Now, 180 out of X are caught. These rabbits are tagged and released back into the reserve. Now, obviously, some of these rabbits will go and mix with the other rabbits. And then on Tuesday, she catches 305 rabbits. Now, remember, this sample will contain some rabbits that she already caught yesterday. There'll be some other rabbits that were not caught, but just random other rabbits. Out of these 305, 45 have tags. Oh, so in the smaller sample, the proportion of rabbits with a tag is 45 over 305. Now, the thing is, these two fractions are approximately equal. So, let's find the value of X. Cross multiplication, really. So, 180 multiplied by 305 is equal to 45x. And I'm just going to divide both sides by 40. And these two 45s get cancelled out. And I can find the number of rabbits. And remember, this is an estimate. So the answer is 1,220 rabbits. And the next part, what assumptions have you made? So the assumptions, there are two assumptions. Part A is this one. This is part B. What assumptions have you made? There are two main things you can say. The tags on the rabbits do not fall off. And the next one is the selection of rabbits is random. Next topic is Venn diagrams and frequency trees. Frequency trees are not that common, but Venn diagrams are quite likely to come up in your exam. Now, here's a typical Venn diagram question, a relatively easy one. Let's have a look. Out of 50 people surveyed, so we know the total, the universal set is 50. 28 have a dog and 22 have a cat. Now, this is the number of people who have a dog. This is the people who have a cat. 28 have a dog, 22 have a cat. Now you can see, if you add these two, you get 50. But also, you get 7 people who have neither dog nor a cat. So, which means there are 7 people outside. And the number of people in these 3 regions should add up to 43 and not 50. See? So, how is that possible? That's because there's an overlap. Now, we don't know the number of the overlap here. There are 2 ways of doing this. You can do this just looking at the overlap, or you can use the algebra. So let's say X number of people have both dogs and cats. The number of people who have just a dog should be 28 take away X. And the number of people who have just a cat would be 22 take away X. Now, I know these 3 numbers should add up to 43. Why? Because 50 take away 7 is 43. So you can do 28 take away X plus 22 take away X is equal to 43. Now, minus X and plus X get cancelled out. 28 plus 22 is 50. Take away X is equal to 43. Obviously, 50 take away 7 is 43. So X is 7. 21 add 7 is 28. 28 add 15 is 38, 40, 43. 43 add 7 gets you 50. That's one way of doing this. The other way is, you know there are 7 here. And you know 50 take away 7. You know these, read all of these values should add up to 43. However, when you just add dog and cat owners values together, you get 50. So 50 take away 43, there's a 7 extra that goes here in the middle. Now I know the number of people who have a dog is 28. 28 take away 7 is 21. That's the number of dog owners. 22 take away 7 is 15. You can put it there. You can choose whatever method you like. Here's a slightly trickier question. Let's have a look at this as well. Out of 100 students surveyed, so I know the total number here is 100. Let's put it here. 60 study maths, 50 study physics, 40 study chemistry. Now you can see these numbers add up to more than 100. So obviously there are some overlapping values. So they're talking about maths, physics, and chemistry. 60 study maths. So that 60 is the total of people in all of these regions. So if you want, you can kind of write it on the edge here. So what that means is it's not just here, because if you write it here, that gives you the wrong impression. Oh, that's a number of students who study only maths. So that's wrong. So if you want, you can just put it on the edge like this, or you can just, keep it here. 50 study physics, okay, 50 on the side. 40 study chemistry, okay. 30 study both maths and physics, okay. So I know maths and physics, that's all of this. That is 30, okay. Now I'm just looking down here. 10 study all three, so I know that is 10 here, obviously. Now 30 study both maths and physics, so maths and physics 30, but I already have 10 people here from all three, so that must be 20. So you can see 30 study both maths and physics, see 20 at 10, 30. So I've used that one. 25 study both maths and chemistry. So math and chemistry is 25. I already have 10 people here. So obviously that must be 15. I used that one too. 20 study both physics and chemistry. Physics, chemistry 20, but I've already got 10 here, the remaining 10 here. Use that one as well. I use that one as well. 15 study none of the three subjects. Okay, so outside here I have 15. Now let's go back to the values that we used earlier. 60 people study maths. I already have 20, 30, 45 people in the other part. So obviously 60 take away 45 is 15. Now look, 15 plus 15 is 30, and 10 is 40, and 20 is 60. Everything works out. So I just found the number of people in here. 50 study physics. So physics, I already have 10 people here, 10 here, 20 here. So 20, 30, 40. So the remaining 10 are the students who study just physics. Now 40 study chemistry. So 40 study chemistry. So 15 and 10 and 10. That's 35. So that's going to be 5. Because 10, 20, 25, 40. Now let's see if all the numbers work, just in case, because everything should add up to 100. So I'm just going to add them one by one. I know everybody inside the maths circle is 60. Okay, so that, and that add up to 60. 70, 80, 85, add 15, you beautifully get 100. Everything works, and here's the answer. The next topic that we can possibly expect is histograms. Now, histograms is a very popular exam question, and they've asked different variations of these things. So we'll discuss one of the common style questions. Now, I'm going to get rid of this. I'm going to need more space for this question. So let me get a question. So here's a typical histogram question you can get. The table shows the time in minutes it took a group of people to complete a puzzle. Calculate the frequency density for each class interval. Now remember, frequency density is frequency divided by the class width. So frequency is 6 here. We are going to write the frequency density here in the third column. Frequency is 6. Class width is 0 to 5. What's a gap? 5 take away 0 is 5. Here 10 take away 5 is 5. 20 take away 10 is 10. Remember, in histograms, they are not always the same. They can be the same, they may be different. 40 take away 20 is 20, just the gap. 40 to 60, that's again 20. So, frequency density of the first one, 6 divided by 5 is 1.2. 18 divided by 5 is 3.6. 24 divided by 10 is 2.4. Now here's the histogram for part B. So on the x-axis is time to complete 0, 5, 10, 15 like that up to 60. On the y-axis it goes up to 8 here. 0 to 5 frequency density is 1.2. Remember y-axis is frequency density. So 1.2. So that's 1.2 here. Next one. 5 to 10, 3.6. So 5 to 10, 3.6. Yeah, 3.6. 3.6 here, 1.2 here. Then next one is 2.4. So this one here is 2.4. Then 1.4. 1.4. And finally, this one is 0.7. 0.7. Next one. Estimate the median time to complete the puzzle. Now, to get the median time, we need to find the total number of people here first. So 6 add 18 add 24 add 28 add 14. Let's get the total. That's 90. So to find the median time, I need to find what about the 45th person. Where does that person go? Now, to work this out, I need to, so the area of each box here gives the number of people. So let's see what's the number of people here. So there'll be 6 here. So I kind of know it from here. And the next one is 18 here. If you want, this width is 5, height is 3.6. So 3.6 multiplied by 5 gives you 18, but we already know it from here, so that's okay. Now let's see how many altogether now. That's 24 people. So I need to add more people. Now the next one is 24 here. So let's count the total now. 6 add 18, 24. Add 24, that's 48. Oh, that's too many. So how many do I need? I need to find the 45th person. So let's look at this one here. And I know this complete red shape represents 24 people. But I already have 24 people here, and I need to get to the 45th person. So if I do 45, take away 24, I need to have 21 people here. So I need to see how far should I go to have 21. So it will be somewhere like this, but I need to figure out what it is. So I need to find where I can get 21 people in this region. Now, I know the height of this, that is fixed, that's 2.4. So if that height is 2.4, and the area is 21, I need to find this gap here. Let's call it x. So obviously, I know x multiplied by 2.4 gives me 21. So I know 21 divided by 2.4 is 8.75, but this value here is 10. So And the gap x is 8.75. So this value here must be 18.75 minutes. So my final answer is median time 18.75 minutes. The next topic that you can expect is cumulative frequency and box plots. So here's a typical cumulative frequency question. A group of 80 students sat a maths test. The scores out of 100 are grouped as follows. 0 to 20, there were 5 people, like that. Complete the cumulative frequency table. Now to get the cumulative frequency table, the first value is 5. Now, next one, 5 add 12 is 17. 17 add 25 is 42. 42 add 30 is 72. 72 add 8 is 80. So a group of 80 students and you get 80 at the end. So this is the cumulative frequency table completion. Draw a cumulative frequency graph. Now when you draw the cumulative frequency graph, you plot cumulative frequency against these values, the upper bound of these. So you can see the plot points here. 25, 20 and 5 here. 40, 17, 40 and 17. 60, 42. So 60, 42. 80, 72. And 180. Now you can join the points with a smooth curve. I mean, I can't really do it that well on this computer, but let me try this. So something a bit like this. Part B. Part C. Use your graph to estimate the median score. So there are 80 people. Median score is the 40th score. So let's go to 40, which is here. And I'm going to go to the right. And then I'm going to go down from there. So in my graph, it appears it's about 58, I would say. So the median score is 58. The interquartile range. Now, interquartile range is the upper quartile minus the lower quartile. So, if you think about these 80 students, so 80, 40 median. Lower quartile is the 20th child, 20th student, and the 60th student here, 40th. So this is the median, this is the lower quartile, this is the upper quartile. So let's find the lower quartile. Go from 20 to the right. Now I have to do some sort of an approximation here. To me, it looks like about 43. And 60, again, you go right from here. That's about 70. To me, it looks like probably about 72. So the interquartile range is this gap here. So my IQR interquartile range is 29. On the grid, draw a box plot to represent the distribution of test scores. Use your estimates from part C. Right, here's the answer for that one. So the median is 58. So that's around here. So that's the median value. And upper quartile is here. That's about 72-ish. Lower quartile is here. That's about 43-ish. Now, the maximum mark, we need to go up to 100 here. It goes from 0 to 20. So we'll have to go all the way down. The next popular GCSE exam question you can get on box plots is about comparing two of them. Now, remember when you compare box plots, there are a few things you can compare. You can talk about range, you can talk about interquartile range, and also median. These are usually the things that we can use to compare. So for an example, if you just look at it, this is class A and class B and their marks. And you can see the range of class A is bigger. It's from here to here. Whereas this one has a slightly smaller range. But you don't say it like that. You need to back this up with numbers. I'll show you the answer in a minute. But that's the idea. Then the interquartile range, you need to subtract the two numbers and find the IQR of these two. They're quite similar, but you can find out which one is bigger if one of them is bigger. Then the median, and you can see in class A, the median mark is higher. Class B, the median mark is relatively low. So here are some points you can say. The range for class A is 85 take away 28, 57. So where do we get these numbers? 85 here, 28 here, and the difference is 57. And for class B, it is 80. You can see it's here. Take away 30, which is here, this one, and it's 50. So class A has a slightly wider range, meaning the marks are more spread out overall. So that's how we can say it. Well, you don't really need to write all of them for GCSE math. If you just write the range for class A within brackets 57 is greater than that of class B within brackets 50, you're fine. What about interquartile range? For A, it's 65 take away 42, that's 23. So this gap here is 23. For class B, it's 68 take away 46, which is 22. So they're very close, I would say, right? However, class A still has a marginally wider interquartile range. You can say the IQR of class A is slightly bigger. Now, the thing is, you need to say this is bigger, this is wider, the worded explanation, and also back it up with some numbers. The median mark for class A is 58, which is here. And for class B, it's around 55-ish, that's right in the middle here. So, on average, students in class A perform slightly better than those in class B. So, that is how you would do a comparison. The next possible topic that you can get is averages and range from tables and graphs. Here you can see a typical question. The table shows the ages of people at a community center. Write down the model class. So model class is where you see the mode or the most frequent number. Now, you look at the frequency and you look for the highest frequency. Highest frequency here is 15. Now remember, the question is model class. So you need to look at the class. Oh, that's this. So the model class is 30 to 40. I've seen many students just look at it and write 15 as the answer. It's not asking the frequency of the model class. It's asking which one is the model class. So you just do that. Work out an estimate for the mean age of people. To get the mean age, we have to take the midpoint. Well, here's the reason why you do that. Now, all we know here is in the community center, there are 4 people between the ages of 0 to 10. We don't know whether they are 5 or 8 or 7 or 6 or whatever. But if you were to take a guess, the best value to guess, if you know they are between 0 to 10, let's assume them to be 5 years old. What about 10 to 20? There were 7 people. So average age would be 15. So you need to get the midpoint between these two. 20 to 30, it's 25. 30 to 40, it's 35. 40 to 50 is 45. 50 to 60, that's 55. Now here, you need to multiply the midpoint by frequency to find the total. 5 times 4, 20. 15 times 7, 105. 25 multiplied by 13, like that. Let's fill them all up. Here are the values. Now, to work out an estimate for the mean age, you need to get the total of this last column here, and you need to divide it by the total number of people, which is the total of the frequency column. Let's do that. The sum of the last column is 1520, and the sum of the frequency column is 50. So to find the mean age, you divide 1520 by 50, and you get the answer as 30.4 years. Last part. Work out an estimate for the median age. Now we know there are 50 people, so we need to see where the 25th person is. So I know there are 4 people here. 4 add 7, that's 11 people, the cumulative value. 11 add 13, that's 24. Now I know the 25th person is here. Now I know the age gap here is 10, and I know 15 people are distributed in that part. So let's assume they are distributed evenly. This last question is quite unlikely to get in GCSEs. Usually what they ask is, they'll ask you, in which class do you get the median? Where is the median age, or in which class does it fall to? So the answer is 30 to 40, like that. But I'll do this question anyway, but it's slightly harder. Well, probably you're not going to get in GCSEs. But what happens is, the gap here is 10, and there are 15 people. If you imagine that they are kind of evenly spread, 10 divided by 15 is 0.666 recurring, so call it 0.67 years. So we already have 4 add 7, 11, 11 add 13, 24, and to find the median age, because it's half of 50 is 25, I need to find the age of the 25th person. Now that person is the very first person in this group. So each person will go up by 0.67 years. So that's 30 years to start with. So the median age will be 30.67 years. The next topic we are going to discuss is about basic and combined probability. Now we kind of discussed about probability in probability trees here as well with the multi-stage events. Let's have a look at another type of a question. This question is linked to probability, and it has some algebraic fractions as well. Pause the video and give it a try. A bag contains only red and blue counters. Okay, red and blue. There are X red counters, so the number of red counters is X, and the number of blue counters is 2 more than that. So the number of blue counters is X add 2. One counter is picked at random from the bag. Write an expression for the probability of picking a red counter. Oh, that's actually quite easy. The probability of getting a red counter, number of red counters is X. The total number of counters is X add 2, which is 2X add 2. Another red counter is now added to the bag. Okay. So the number of red counters is now X add 1. A count is picked at random. Write an expression for the probability of picking a red counter now. Now, the new probability of getting a red counter is the number of red counters X add 1. Now, what's the total number of counters? We have X add 1 red counters and X add 2 blue counters. The number of blue counters does not change. So it's X add 1 and X add 2, which is 2X add 3. Here's the answer for the second part, part B. Part C. The probability of picking a red counter now is 3/7. form an equation and solve it to find. Oh, that's pretty easy. So PR, they say this is 3, 7. So all you need to do is do x add 1 over 2x add 3 is equal to 3 sevenths. Now I'm going to put brackets here and let's do cross multiplication. So 7 times x, 7x plus 7 is equal to 6x plus 9. Move the 6x to this side, move the 7 to the other side. 7x take away 6x is x is equal to 9 take away 7, 2. So the value of x is 2. The next possible question we can expect is listing outcomes and using sample space. Now, sometimes these two can be sort of connected in one question as well. Let's have a look at a question or two. Please pause the video and try this question. When you're ready for the answer, press play. Amir spins a fair spinner with numbers 1, 2, and 3. Okay, so Amir has a spinner and this has numbers 1, 2, and 3. Bella rolls a fair six-sided die with faces numbered 1 to 6. It's a normal one with 1, 2, 3, and you have 4, 5, and 6 in the hidden sides. They do this just once, okay? List all the possible outcomes for the sum of the number Amir gets and the number that Bella gets. Okay. Now, here's what we can do. So, Amir's spinner has numbers 1, 2, and 3. Bella's die has numbers from 1 to 6. So, now, list all the possible outcomes for the sum. So, let's get the sum. 1 add 1, 2. 1 add 2, 3. 1 add 3, 4. 2 add 1, 3. 2 add 2, 4. 2 add 3, 5. 3 add 1, 4. Now you can see there's a pattern 2, 3, 4, 5, 6, and 7. 6 add 1, 7. 3, 4, 5, 6, 7. So here are all the possible outcomes. Part A, done. Part B, find the probability that the sum is a prime number. Now, how many numbers are there altogether? 3 times 6. I've got 18 numbers here to choose from. Now, how many of these are prime? Prime numbers are numbers that can be divided by 1 and itself only to get a whole number. Example, 2 is the first prime number. 1 is not prime. 1 has only one factor, so not prime. 2, 3, 5, 7, 11, ... These are the prime numbers. So what are the prime numbers here? 4 is not prime. Obviously, none of the even numbers are prime except for 2. So 2 is the only even prime number. So that is 1. That is prime. So let's just highlight all the prime numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 of them are prime numbers. You can leave it as it is because it's probability, because it's half. You can write it like that as well. Here's a sample space style question. Let's pause the video and give it a try. Here's the answer. A coin is flipped and a spinner with 4 equal sections numbered 1 to 4 is spun. So there's a spinner. This has 1, 2, 3, and 4. And the coin has head and tail. List all the possible outcomes. Now, you can do this as pairs, or you can just do this on a sample space diagram. So in the sample space diagram, here's the coin, and we can get either head or tail. And the spinner can have any number between 1 to 4. So let's do 1, 2, 3, and 4. So we can get these two, these, and these. So we can write it as a list here. So we can get head and 1, head comma 1, head and 2, head 3, head 4. Similarly, we can have tail 1, tail 2, tail 3, tail 4. So there are 8 possible outcomes. Find the probability of getting a head and an even number. So let's look through the head here, an even number. Here's head and even. And here's head and even. And it's 2 over total number is 8, which is a quarter. Find the probability that the result is a tail or a number of greater than 2. Now there are 2 conditions. If it is a tail, that, and all of these things count irrespective of the number. Or a number greater than 2. So 1 and 2 don't count, but 3 and 4 count. 4 and 2, 6 out of 8, which is 3 quarters. The last section is about vectors, vector notation. There was one vector question, but that was a smaller one, so you can probably get another one. There's a chance. And vector geometry problems. Let's have a look at that. And then we'll look at some inequality region questions. So here's a vector question. If you want to try this question, pause the video and give it a try. Let's have a look at the answer. The diagram shows a triangle A, B, and C. The vector AB is A. Okay, so I'm going to mark it. This is A. AB. And vector AC is B. Okay, so let's mark this as B. Point D lies on line BC such that BD to DC is 2 to 1. So it's kind of close to C. So here's your point D, and the ratio is 2:1. Here's point D, and the ratio is 2:1. Point E lies on the line AB such that AE to EB is 1:2. So E is around here. Again, it's 1 and 2. 1 part here, 2 parts there. Right. Find BC in terms of A and B. So BC. Now you can clearly see BC is BA plus AC. So think about it like this. You can go from B to C along this route, or you can come from B to A and then A to C. So BC is BA plus AC. Now, what's BA? BA is negative A. Why negative A? Because AB is A, so BA must be negative A. And AC is just B. So first one, the answer is negative A plus B, or B minus A. Find BD. Okay, where's BD? BD in terms of A and B. Now that's pretty easy because I can clearly see BD here is 2/3 of BC. But I already know what BC is here. So all I need to do is BC, which is negative A and B. And I need to multiply this one by 2/3. So I can write, if I want, I can leave it like that, or I can use 2/3 A negative add 2/3 B. That's the second one. Third one, find AE. So AE, oh, that's actually pretty easy because AE is simply 1/3 of AB. And I know AB is A, so that's literally 1/3 A. It's very easy. Last part. Find DE in the form lambda A plus mu B. So DE. Let's join D and E. DE. This one here. Now, DE, now again, like before, I can go from D to E this way, but alternatively, I can go from D to B and then B to E. So I can write DE is equal to DB plus BE. So what's DB? Now, I already know BD here. BD. BD is this. So what's DB? I need to multiply this one whole thing by a negative sign. So this negative 2/3 A becomes just positive 2/3. This positive becomes negative 2/3 B. Why? Because BD is negative 2/3 A plus 2/3 B. DB must be positive 2/3 A. Take away 2/3 B. So that's my DB. So this is DB. Let's find BE. BE, I know this is 2/3 of the shape here. BE is negative A multiplied by 2/3. Negative A because I'm going from B to E and A is pointing the other way, so that's negative, and I need to take 2/3. I need to just do some simplification here. Now, I can see here, I can collect the A terms, so I have 2/3 A, and this is negative 2/3 I, and I have negative 2/3 B. Now you can see 2/3 A and 2/3 A gets cancelled out, and the answer is negative 2/3 B. So the value of mu here is negative 2/3, and this lambda here is 0. Here you can see a question about inequalities, inequality regions. This is also a quite likely question that you can get in your paper 2 and 3. Please pause the video and give it a try. On the grid, shape the region that satisfies all these inequalities. So you have 3 here. Let's start with 1 by 1. And you need to label the region R. Now, before we do that, we need to plot the graph y is equal to 2x add 1. To find y is less than or equal to 2x add 1, we need to get y equals 2x add 1 line. Now, to do that, you just need to take 3 values of x, and then let's plug this in. 2 times 0, x is 0, is 0, add 1 is 1. Let's put 2. 2 times 2 is 4, add 1 is 5. Let's put 4 for x now. 2 times 4 is 8, add 1 is 9. So 0, 1. So 0, 1 here. 2, 5 is here. 4, 9 is here. Because I have less than or equal to, because I have this equal sign, I can leave this as a solid line. If I only had less than or more than, I have to turn this into a dashed line. But for now, it's okay. Let's do the second one. Y is more than or equal to, let's get the equal one first. Y is equal to negative x add 2. So let's get some x and y values. Let's take x is equal to 0, 2 and 4. When x is 0, the value of y is 2. And let's put x is equal to 2 here. So negative 2 plus 2, that is 0. And let's put 4 here. Negative 4 add 2 is negative 2. So I got 3 points. So let's try and draw that one. 0, 2. So 0 and 2 here. 2, 0. X is 2, y is 0 is here. That's the next line. So I got the first one and the second. Now the other one is x is less than or equal to 4. So I need to draw x equals 4 line. X is equal to 4 line. Let's draw that. So it should go through 4. It should cut through number 4 on the x-axis. Now let's see where the region is. So the first one says y is less than 2x add 1. Now 2x add 1 is this line. Less than side is anything to the right of it, like that. All of this. Next one, y is more than minus x add 2. This is the minus x add 2 line. So y is more means above. So all of that. The last one, x is less than or equal to 4. So it's all of this. Now if you think about this, when I did all of this coloring, the common region that gets colored by all three is this one here. Let me show this again. This is y is less than 2x add 1. It's less than this line. It's more than this line. And it's also x is less than or equal to 4. Completing the square and solving quadratics is a very common GCSE exam style question. I've seen this in Edexcel papers in many years. So please give this question a try. I'll do the question when you're ready. Solve the equation 2x squared minus 8x add 3 is equal to 0 by completing the square. Give your answers in the simplest third form. Okay, so I'm going to complete the square, but I have a 2. So what do I need to do? I need to factorize. Let's take 2 out. X squared, take away 4x. I don't need to factorize the 3, so let's just leave it outside. Is equal to 0. Now to complete the square, I need to add half of this squared. So half of negative 4 is negative 2. Negative 2 squared is add 4. But I can't just add 4 out of nowhere. To balance it, I have to put minus 4. Some people do completing the square slightly differently. Doesn't matter. You'll get to the same answer either way you do. So we'll see. So 2 bracket. Now I know this here is x take away 2 everything squared. That's a complete square. And then I have this take away 4 at the end. Add 3 is equal to 0. So multiply these out. 2 bracket x minus 2 everything squared. Take away 2 times 4 is 8. Add 3 is equal to 0. So simplify this further. 2 bracket x minus 2 everything squared. Minus 8 plus 3 is minus 5 is equal to 0. Move it to the other side. 2 bracket x minus 2 everything squared is 0 and 5 is 5. Now I'm going to divide both sides by 2. So I can cross these two out. So I get x minus 2 everything squared is 5 over 2. Now I need to take square root of both sides. So I need to root both sides. So let's do that. X minus 2 is equal to plus or minus square root of 5 over 2. Move this to the other side. X is equal to negative 2 becomes positive 2. 2 add root 5 over root 2 or 2 minus root 5 over root 2. Now, in the simplest third form, it's a good idea to rationalize this. So multiply this top and bottom by root 2. Here also you can do the same thing. So my final answer here is x is equal to 2 plus root 5 root 2 is root 10 over the 2 root 2's just become a 2 or 2 minus. So that's the final answer. Here's another question linked to completing the square. You can get questions like this in your paper 2 and 3. So please give this a try and wait for me to talk this through. The quadratic expression is given by y is equal to x squared minus 6x add 5. Write the expression in the form this. So you just need to complete the square. Let's do it here. Y is equal to x squared minus 6x. And I'm going to move this plus 5 out. You need to half this number and square it, and you add it here. Half of negative 6, negative 3. Negative 3 squared is plus 9. But you can't just plus 9 out of nowhere because that wasn't here. So you need to take away 9 to balance it out. Now, all of this is x minus 3 everything squared. So y is equal to x minus 3 squared minus 9 add 4. We have negative 4. So write the expression in the form y is equal to x, take away a. A is 3 and b is negative 4, where a and b are numbers. Done. Part B. State the coordinates of the minimum point of the graph. Now, when you look at this one, to get the minimum point, what you do is this value here is simply your y coordinate, negative 4. To get the x coordinate, you need to get this value, one inside the bracket, but you have to change the sign. So negative 3 becomes 3. So the minimum point here is 3, negative 4. Sketch the graph of y is equal to x squared minus 6x add 5. Now, we know the minimum point is 3 and negative 4. But we also need to find where it cuts the x-axis. So to do that, what you need to do is you make y is equal to 0. So when y is equal to 0, let's substitute in this black one here. X minus 3 everything squared, take away 4 is equal to 0. And let's solve it. X minus 3 squared is equal to 4. Oh, so you need to square root both sides. X take away 3 is equal to plus or minus root 4 is 2. Now move the 3 to the other side. X is equal to 3 plus 2 or 3 minus 2. Now 3 add 2 is 5 or 3 take away 2 is 1. Here's your y-axis. Here's the x-axis. And because of this shape, I know it's a U-shaped curve. The minimum point is 3, negative 4. So 3 and negative 4. So here's the minimum point. And it goes through 1 and 5. So 1 and 5. So the shape of the graph is something like this. Now, I've already marked the 2 points at which it cuts the x-axis. The y-intercept. To find the y-intercept, you need to make x is equal to 0. Now, when x is equal to 0, let's put it in here. Y is equal to 0 squared minus 6 times 0 at 5. So all of this is literally 0. So y is equal to 5. So I know it cuts the y-axis at 5. Then I need to draw the axis of symmetry. So here's the axis of symmetry. So I got the axis of symmetry, minimum point, and y-intercept. Here's another possible question that I've seen in exam papers in the past. A line passes through the points 2, 5. 2, x-axis, 5, and this is your point A. And B, 6, negative 3. X-axis is 6, y-coordinate is negative 3. So that's your point B. Find the equation of the line in the form y equals mx plus c. Now, it's very easy. The first thing you need to do is you need to find the gradient of this line. To find the gradient, I need to do delta y over delta x, or change in y over change in x, or some people think of this rise over run, doesn't matter. So here's delta y. It's from 5 to negative 3, that's 8. So it's 5 to 0, 5, 0 to negative 3, 3 more, 5 and 3, 8. And delta x here is from 2 to 6, that is 4. So 8 divided by 4, the gradient is 2. However, the line is going down, so it has a gradient -2. So that's the first thing. Now, we know the equation of this line is in the shape y is equal to mx plus c. So I already know my m is -2. I need to find c to get the final answer. To get c, I need to have some x and y values. I have two pairs here. I can use this pair or this pair. I would personally use the positive pair because it makes things easier. So your x value here is 2. I'm going to put 2 here. And the y value is 5. So I'm going to put 5 here. 5 is equal to -2 multiplied by x is 2 here, add c. So 5 is equal to -4 add c. 4 goes to this side, becomes addition. C is equal to 5 add 4, 9. So my final answer, y is equal to gradient is -2x add 9. Here is another question that you can possibly get in your GCSE Maths paper 2 and 3. This question is about a frustum, and you need to use the ideas about similar shapes as well. Give this question a try, and you can check the answer with me when you're ready. A solid is made by removing a small cone from the top of a large cone. So this is the large cone, the small cone is at the top. The large cone has a height of 12 centimeters. The whole thing is 12 and the base radius is 6. Okay. The small cone that is removed has a height of 4 centimeters and is similar to the large cone. So what you do is you cut it from here, this. So this one is 4 centimeters. Now the question is, the remaining solid is a frustum. Yes. So here's the frustum. Work out the volume of the frustum. Now to find the volume of the frustum, all you need to do is find the volume of the big cone and find the volume of the small cone and take them away. Now, before you find the volume of the small cone, we need to know the radius here. But these are similar shapes. So you can see 12 to 4. So obviously 12 is divided by 3 to give you 4. Obviously 6 should be divided by 3. So the radius here is 2 centimeters. Volume of any cone is given by the formula 1/3 pi r squared h. So the volume of the big cone here is 1/3 pi. Radius is 6 squared multiplied by the height is 12. Now from that I need to take away the volume of the smaller cone, that is 1/3 pi. Radius is 2 squared multiplied by the height here is 4. If you want, you can now factorize the 1/3 and pi out, and then you can do the rest of it, or you can just do the simple thing. Now, since it is a calculator paper, you can directly put this whole thing to the calculator. So this one gives me 144 pi. Take away, that gives me 16/3 pi. Let's just take this one away from 144 pi, and your final answer is 416 divided by 3 pi. So that's pretty much it for paper 2 and 3 predicted questions. Make sure you're revising those key areas, especially algebra, geometry, and those tricky worded problems. So if paper 1 is anything to go by, there's definitely a pattern to prepare for. You've got this. Keep going, and I'll see you in the next one. Good luck with paper 2.